So hello everyone, and I'm now generating part 4. We're back with this hairy stuff on correlation and covariance. So anyway, this is a table that's in your book, and what it's showing is historical volatilities or standard deviation. So these are standard deviations here, right, for these different companies: Microsoft, HP, Alaskan Air, Southwest, Ford. And I guess they get these off the web. I don't know how. I don't think they generate these. So if you want to somehow figure out where they get these historic volatilities from. All right. So basically what they're showing you how Microsoft is correlated with and how each of these companies is correlated with all the others. So obviously Microsoft is correlated with Microsoft, right? Is a 1. It makes sense, right? HP is correlated with HP is a 1. So you can see any company correlated with itself is a 1, right? So Southwest is a 1. So, okay. But the important stuff is Microsoft correlated with like HP is a 0.4. So you can see if when one goes up, they're kind of like in the middle, right, of movement-wise. They're not totally correlated. And obviously, it's interesting because obviously, look, Microsoft and Alaska Air, there's really very little correlation. There's not much, they don't move in the same direction all the time, right? So, but they're showing it, and especially look at Kellogg. Basically, there's no correlation at all between Microsoft and Kellogg for the most part. They just don't move together, okay? And so you could see that, and I don't see the interesting thing is I don't see anything negative here in this table. There's no negative correlation. So, but in any case, this is basically historical data that, and I guess if you took this volatility here, right, and calculated the the correlation here, especially after you get the covariance, you would use the covariance and the standard deviation, and you would get these correlations. But anyway, it's a historical data table. Don't worry too much about it. Don't stay up late trying to calculate it all. It's probably in someone's database somewhere. All right, so there's an example here in your book, 11.4, and we'll go over that. Let me just lower my phone. All right, so using the data in table 11.1, what are the correlation between North Air and West Air, between West Air and Tex Oil? All right, so let's see what they do here. All right, so with the returns that are shown in the previous table way back when, in table 11.1, I think that was in part 1, right, of the video, we start doing the math. We subtract the mean return from each and compute the product of these deviations between the pairs of stocks. All right, we then sum them and divide by, again, it's t minus the number of periods, right? T minus 1, it was 6 years, but we subtract 1, and that's 5, to compute the covariance as in table 11.2, right? So we get the covariance. So we saw that they had a positive covariance, right? Indicating a tendency to move together, whereas West Air and Tex Oil have a negative covariance, indicating a tendency to move oppositely. We can assess the strength of these tendencies from correlation obtained by dividing the covariance by the standard deviation of each stock. The correlation for North Air and West Air is 62.4, and the correlation for West Air and Tex Oil is 71.3. Now, I don't know if they show you in your book, but probably not. But anyway, it's probably done in your book, but it's not shown in the slides here. And again, they ask another question, right? What is the covariance between Microsoft and HP? And again, you could forward this data if you'd like, or if you really need help, just email me and we go through it. This is all readily accessible to do in Excel. Obviously, this whole thing could be set up in Excel. And basically, so here's another alternative examples, right? And they show you the math, so. All right, so looking at these equations again, for a, whoop, oh, go back, get back there, you. All right. For a 2-security portfolio, the variance is the covariance, right, of RP and they show you this here. So here's how you calculate the variance from the covariance, okay? Again, don't get too bogged down in this math, all right? But this is how you get the variance if you're given the covariance. So little P stands for portfolio here. So the variance of a 2-stock portfolio, after all is said and done here, is x1 squared times the variance of R1 plus x2 squared times the variance of R2 plus 2x1, x2 covariance R1, R2, right? So this is x1 squared, right? And there's x2 squared. All right. So again, don't be, this is painful, but don't get too bogged down. Most likely you won't see too much of this on an exam, except for maybe some definitions. All right, so here's a textbook example computing the volatility of a 2-stock portfolio. And again, they go through the math here, and it just gets out of control here. So this is from the previous slide, the equation that was up there. There's a couple more examples here. And they're just good to go through. And here's all the math. At least they give you the math here so you can follow. All right, so I'll stop here before I include we make the portfolio any larger, all right?